So hello students, in this class we have to study about the virtual functions and abstract classes mainly. But to move on to the virtual functions and abstract classes, before I will follow this methodology. First we will discuss the overview of inheritance in public mode, that how a derived class can inherit the base class in public mode. Specifically we will concentrate on public mode. Then we will get an overview about overloading. Overloading and overriding are two different terms and they are two different forms of polymorphism. So first we will discuss about overloading, and after that we will discuss about overriding. When we are clear with the concepts of overriding, we will move on to the virtual functions, and after moving on to the virtual functions we will see what is the difference between a virtual function and a pure virtual function, and then we will study about the abstract classes. After abstract classes we will discuss what are interfaces. So let us start. First of all, let us see inheritance in public mode. See here, I have made a class base. The name of the class is base, and obviously it is the base class also. Here the class is derived and this is the derived class. That means this class will inherit this class. You can give any name though. Class base, and I have divided the class in three sections: private, public and protected. There can be some data members in private, public and protected. There can be member functions in private, public and protected, and here the class gets over. And here I have made a derived class that is inheriting the base class in public mode, and also here there are three sections: private, public and protected. So this derived class is inheriting the base class in public mode. Public mode means all the data members and member functions that are present in the base class will be exactly inherited in the public section of the derived class, and all the data members that are residing in the protected section will be exactly inherited in the protected section of the derived class. That means the public members to the public section and protected members to the protected section of the derived class will be strictly inherited. But this private data members and member functions will remain here, because in any case private data members and member functions can never be inherited. That is their property. Only public and protected can be inherited. So in case of public mode, public data moves to public section of derived, and protected data of base moves to protected section of derived. This was the concept of inheritance in public mode that we need to discuss before starting further. Now let us see overloading. So see here, first of all let me tell you one raw definition of overloading. You can note it down, I will speak. Overloading means defining two or more functions with same name, but they are differentiated using number of arguments and type of arguments. Overloading means defining two or more functions with same name and they are differentiated using number of arguments and type of arguments, and moreover this overloading can take place with respect to only single class. That means there should be only one class. In that class there can be two or more functions with same name, and they are differentiated using number of arguments and type of arguments. So now let us see this example. Here I have made a class area. The name of the class is area. In the private section, I have declared one integer variable a. That means this integer variable a will not be accessible outside the class because it is in private section, but inside the class it can be accessed easily. Then there is one function named void area, which is taking two integer arguments, int l, int b. L is integer, b is integer, and they are being multiplied together, L into B, and that the result is assigned back to A. After that there is cout statement, area of rectangle is, and A is printed on the screen. The value of A is printed. Then the next function says void area. There is only one argument of integer type, that is side. We multiply side with the side itself and assign the result to the variable A. Then area of square is printed on the screen along with the value of A. So there are two functions, area, but here there are two arguments of integer type, but here there is only one argument of integer type. So the functions are differentiated on the basis of number of arguments here, and also they can be differentiated on the basis of type of arguments. Like here we can also write, we can make one more function void area, and there we can put float side. Then what will happen? The argument number is same, but the function would be differentiated basis on the type of argument, one of integer side and one of float side. So both can be the characteristics. Number and type of arguments will differentiate the two or more functions if they are made in same class, and this concept is called overloading. Overloading simply means defining two or more functions with same name but different forms, differentiated on the basis of number of argument and type of arguments within a same class. Now how to access which function, this we have to study. See, if I create object of this class area, suppose I have created an object named OB, then what will happen? I have written OB dot area 4,5. If I put this statement in the main function of the program, that is in the void main, then what will happen? The object OB is the object of class area, and using dot operator it is calling the area function with two integer arguments. Then obviously this function will be invoked because it will only accept two arguments of integer type. So what will happen? L will get 4, B will get 5, and A is equals to 4 into 5. A will get the value 20, and area of rectangle is 20 will be printed onto the screen. Then if I put a statement like this, OB dot area 4, then there is one argument of integer type. Obviously this function will be called because this is accepting one argument of integer type. A is equals to 4 into 4, area of square is 16. So this is how overloaded functions can be invoked in a OOPS program. Now let us move to the concept of overriding. So see this, here I have made a class named base, and in the public section I have declared a function named fun1, and the statement in the fun1 function is cout function of base /n. That means whenever this function will be executed, function of base will be printed onto the screen. Okay, now another function is void fun2, and there is only one cout statement, function of base. So what will happen? Whenever this function will be executed, function of base would be printed onto the screen, and here the base class ends. Then I have made a derived class. In that derived class, derived class is inheriting the base class in public mode. Now as the concept of inheritance that we studied here, we studied that the public section of the base class is directly copied to the public section of derived class, and protected section of base class is directly copied to protected section of derived class. Similarly, this is all in the public section of the base class. So this all will be copied into the public section of the derived class after inheritance. So in total 1, 2 and this 3, total 3 functions would be there in the derived class after inheritance. And the main function that is there in the derived class, the function that is the derived class is owning prior, is this fun1, and here there is one cout statement, function of derived. So first of all, I am speaking the definition of overriding. Please note it down. Overriding means if there are two classes, one is the base class and other is the derived class, the derived class is inheriting the base class, then if base class and derived class is carrying a function with same name, then what will happen? Overriding will override the function which is present in the base class and it will vanish. So I suppose you have written the definition in your notebook. Now let us understand this definition. Suppose here it is the image of derived after inheritance. After inheritance, what will happen? This fun1 and fun2 of base will also come into the derived class, and derived class own function is void fun1. This is also pre-existing here in the derived class. So overloading will say that there are two functions now of the same name, fun1 and fun1. So what I will do, I will override this fun1 so that this fun1 will vanish from here. See, the fun1 of base class vanished from here and only fun1 of derived class is now existing. This is the concept of overriding. When two or more functions with same name come in a class after inheritance from some another class, then overriding will play. So what happened exactly? Fun1 of derived class overrided or augmented the inherited fun1, and so by object of derived class fun1 of derived will be called. That means if we will create an object of derived class, say derived D, we have created an object D, then if we will write D dot fun1, then what will happen? The fun1 of this own derived class will be called, because fun1 of the base class which was copied here after inheritance has vanished due to overriding. So let us understand this again with the help of example. Class base public void fun1 one statement, void fun2 one statement. In the class derived, it is inheriting the base class in public mode. So fun1 and fun2 will come here, but fun1 is also here. So this fun1 will not be able to inherit, because after inherit it will vanish. Only fun2 will be inherited here and will play easily. Fun1 will inherit, but it will act that if it has vanished, it will not play. Okay, in the memory fun1 and fun2, three functions would be there, but fun1 of base cannot play because overriding has been done. Okay, now see, void main base B. That means B is an object of class base, and derived D, that means D is an object of class derived. We have created the objects of both the classes. Then from B object we are calling fun1. The object B dot fun1 is written. That means B is calling fun1. B is the object of class base. When we will call from the object of class base the fun1 function, obviously fun1 of the own class will be called. That means B is the object of class base, so fun1 of base will be called, and the line will be printed function of base. See, the output is there, function of base. Then I have written here D dot fun1. Now when D will go to search fun1 here, D will get two fun1s. One fun1 will be of base class that is inherited here, and one fun1 will be of derived class which is inherited here. But due to the concept of overriding, D will see that fun1 of the base class I cannot use because it is vanished due to overriding. Actually understand this concept. In actual the function will not go anywhere, it will not vanish, but it will behave like that. Okay, so D will see that there are two fun1, one of the base class that is inherited and one of the derived class that is already existing. So obviously as D is the object of derived class, the priority is given to the main function that is pre-existing in the derived class, and the fun1 which is inherited from the base class will not be able to play. That is why we called it will vanish, simply to understand the concept. Okay, so fun1 of derived class will be called and statement would be printed function of derived. See, function of derived is the second output. Then we call d dot fun2. Now fun2 was inherited here in the derived class from the base class, but as fun2 did not have any competitor function with another function named fun2, so this fun2 can easily play here. And when we called from the object of derived, as fun2 is already inherited here, fun2 will execute and function of base will be printed. See, function of base. I hope you got the concept clear about overriding. The fun1 of the base class is getting inherited, there is no harm in that, but it is not able to play with the object of derived class because object of derived class will give preference to the function which is pre-existing in the derived class, that is the function which is own of the derived class. I hope you got the concept clear. What is overriding? Okay, now we will study about virtual functions. For studying virtual functions, the concept of overriding was very important. That's why we discussed it. Here there is one class named base. Okay. Then in the public section there is one function virtual void fun1. Void fun1 is the function and we have prefixed a keyword named virtual, and there is one cout statement function1 of base, and there is one another function void fun2 cout function2 of base. So see here, fun1 is having the keyword virtual but fun2 is normal. Okay, note this. Then there is a derived class which is inheriting the base class in public mode. Then what will happen? This fun1 and this fun2 will be copied to the public section of the derived class. So now see, in the derived class there is one more function named fun1, which is derived's own function. One fun1 is inherited from the base class, that is the virtual function, and one fun1 which is already existing here in the derived class, which is having the cout statement function1 of derived, and one fun2 is also inherited here. So now let us see by running this what will happen. Base star bptr. This statement means I have created a pointer object of the class base. What is the difference between a normal object and a pointer object? A pointer object will store some address. What address? Obviously the address of the variable that would be of base type. Suppose I have an integer variable int a and I want to store its address. Then what I will do, I will create a pointer int star ptr and I will assign the address of a to that ptr. That means the pointer variable is also declared as int if I want to store the address of some integer variable. Similarly, here base star bptr is written. That means a pointer object of type base is created, and obviously this pointer object will have the address of some class type only, class object type only. Okay, so now let us see. Here there is another statement derived d. D is normal object of the class derived. Now as D is the normal object, it will be going to store the values the class has defined, or it will be used to run the function that are defined inside the class. See here, bptr is equals to ampersand d. Now as I told you, this bptr will store the address. Therefore I gave the address of d to bptr. Ampersand means address of. bptr is storing the address of d. Then using this bptr, I have invoked fun1. I have invoked fun1. Why I am using arrow operator here? Because bptr is the pointer object. If using the pointer object I want to invoke any function of the class, I will use the arrow. If the object is normal, not a pointer object like d, if I access using d, I will use dot operator. But as it is pointer object, I am using arrow operator. Using the pointer object bptr, I am calling fun1. So what will happen? bptr is the pointer of base class, obviously, as here base star bptr. But bptr is having the address of d. See here, I have assigned the address of d to bptr. So when I will invoke fun1 using bptr, what will happen? As bptr is having address of d, despite going to the base class, bptr will go to the derived class because bptr is carrying the address of d. Address of d means derived class. D is the object of derived class. So obviously we will go to derived class, and when bptr goes to the derived class, it accesses fun1, and fun1 here is written function of derived. When it will execute, function of derived will be printed onto the screen. Now this concept is called late binding, or we can call it runtime polymorphism. Why it is late binding? Late binding simply means not calling the function that is defined in the base class, but deliberately going to the derived class and calling the function fun1 that is defined in the derived class. That means bptr is the object of base, but because I assigned the address of d, and as d is the object of derived class, I assigned the object of derived class address to bptr. So despite executing this function of derived is being executed. Therefore we call it late binding. Late binding means not calling this before, but going to the second step directly, that is of the derived class. Late binding. bptr of fun2. Now late binding, let us once more look at the late binding, why it is being called late binding. As keyword virtual is also written here, what will happen when this program will run? when we will run this program, and BPTR will go to the derived class. BPTR will see that fun1 is existing here also, and fun1 is existing which is publicly inherited here also. That means there is one virtual function also existing here, and one normal function fun1 is also existing here. But as fun1 is normal also and virtual also, the virtual one will not run due to overriding, because this will vanish. It will not vanish, but it will behave like that, and the preference would be given to this fun1, and that is why function 1 of derived is done here. That means using virtual functions, writing the virtual keyword, we are implementing the overriding here. Then BPTR of fun2. This fun2 is normally inherited here, and as fun2 is now also a member of derived class, then BPTR can access fun2, and function 2 of base would be printed, function 2 of base. Now D is the normal object, so I will use the dot operator, D dot fun1. D dot fun1 means this, again function 1 of derived, function 1 of derived. D dot fun2, D dot fun2 means this was inherited here, so function 2 of base. Virtual keyword implements late binding, resulting in runtime polymorphism. Runtime polymorphism means at the runtime of the program, it is being decided which of the two functions we have to execute. As this was virtual, so this was not executed because it was overridden by the fun1 of derive. I hope you got the concept of virtual functions here, how it is related to overriding. Okay, so the main concept was here, to the pointer object we assigned the address of D, so the preference would be given to the derived class. Simple. Now let us see the concept of pure virtual functions. Pure virtual functions does not have any body. See here, class base. In the public section, I have written virtual void fun1 is equals to 0. Only one statement. There is no body. Instead, I have assigned 0 to the function header. Virtual void fun1, no body, no curly brace, no statement inside this function, simply is equals to 0. So this is the concept how to write a pure virtual function. If we want to make any function, any virtual function as pure virtual function, what we will do, we will erase the body and write is equals to 0. Okay. Then there is one normal function named fun2. There is one cout statement in this function 2 of base. There is a derived class which is inheriting the base class in the public mode. In the public section of the derived class, there is one fun1 which is printing function 1 of derived, and this virtual void fun1 will also be inherited here, and fun2 will also be inherited here. So now let us see the main function. Inside the main function, we have created a pointer object of the base class, normal object of the derived class. To the pointer object of the base class, we have given the address of D, and D is the object of derived class. That means whenever we will say BPTR, BPTR will be forced to move to the derived class. Then using the arrow operator, BPTR is accessing fun1. What will happen? BPTR is accessing fun1, function 1 of derived is simply printed onto the screen. BPTR is accessing fun2. This fun2 is inherited here, so function 2 of base will be printed. D dot fun1, obviously this function, fun1 of derived, function 1 of derived will be printed. Then D dot fun2, this is inherited here, so using the object of derived class, we can access this also, function 2 of base. So it was simple. There was no difference as such in this program and this program, only here we have implemented it using pure virtual function. We have not defined the body of the function. Instead has put it equal to 0. This is the main difference between virtual function and pure virtual function. In virtual function, see, we have to define the body. There is the body. There is one cout statement in this. Though this fun1 is never executed, but we have to define it. Okay. But in pure virtual function, we will not define the body. Now, why do we don't define the body in pure virtual function? This relates to the concept of interface. This pure virtual function, the class that is having the pure virtual function can be used as interface, and the class that has, note this down, and the class that has at least one pure virtual function in it is called the abstract class. That means this class named base is called the abstract class because it is having one pure virtual function. The criteria is that one pure virtual function must exist to call a class to be abstract class. I hope you got this point. So see here the definition of abstract class. Abstract class is a class which contains at least one pure virtual function in it. Abstract classes are used to provide an interface for its subclasses. This we will see what is an interface. Classes inheriting an abstract class must provide definition to the pure virtual function. That means in the base class where the pure virtual function is defined, there the body should not exist. But in the class that is inheriting those base classes, we have to define the body of that pure virtual function. See here, here the body of fun1 is not there because it is pure virtual function. But derived class is giving the body. Fun1 we have defined here also. Here we have defined the body function 1 of derived. So derived class has to define a body for a function which is declared as pure virtual in the base class. This is the concept. Classes inheriting an abstract class, here abstract class was base class, must provide definition to the pure virtual function, otherwise they will also become abstract. That means if here also we will skip the body of this one, obviously this will also become abstract. Why it will become abstract? Because if we discard the body of this one here also, then what will happen? As the body is not there, fun1 is inherited here, and when fun1 is inherited here, this fun1 was pure virtual, and when the pure virtual function is inherited here, obviously the class will become abstract because the definition of abstract class says one pure virtual function must exist. So pure virtual function will be inherited here, and see that fun1 is also not being defined here. When the function 1 is also not defined here, this class will be ultimately called abstract class because body of fun1 is still not found. Till the time in any of the classes the body of fun1 is not found, we will say all those classes as abstract if they are inheriting this base class. Okay, there are some properties of abstract class. We will get back to these properties once we see an example. See, class base public virtual void fun1 is equals to 0, but void fun2 function 2 of base, class derived inheriting the base class in public mode, void fun1. Now pure virtual function is defined, is declared here, not defined. Defined means writing the body, so we cannot use the term defined. Okay, pure virtual function is declared here and defined in the derived class. The body is given in the derived class. If the body was not there, what will happen? This pure virtual function will inherit here. It will see that body is still not here. Then this derived class will also become abstract class. But as the body of fun1 is there, this derived class will vanish, will override this function of the base class and give the access to the fun1, and this statement can be printed. In that case, derived is not becoming abstract. But if we skip the body of fun1 here also, it will again become abstract. So same function is there, same output would be there. I hope there would be no doubt in running this. See this example. We will see how pure virtual function is implementing the interfaces. Interface simply means that we have to use a class in many ways depending on our capacity. See, depending on our need. See, I have declared a class named shape. In the public section, I have made one pure virtual function, virtual int area equal to 0. Then I have made two normal functions, void set underscore width. It is having one argument of integer type, assigning that w to width. Void set height, one argument of integer type h, assigning that h to height. Int width and int height are declared in the protected section. Okay. Then why they are declared in the protected section? So that they can be inherited. They can be moved to the derived class. If I declare in the private section, then private section cannot be inherited. Okay. Then class rectangle, which is inheriting shape in public mode. That means all the data of public in the public section of rectangle and all the data of protected in the protected section of rectangle. As there is no protected section here, the compiler will self create it so that width and height can come here. Okay, so now what will happen? This pure virtual function will inherit here. When this pure virtual function will inherit here, it will see the body of area is defined here. So it will run that body, return width into height. Width and height, it will be given from these functions. This set width and set height will also be inherited here. So whenever w and h will be called, the set width and set height would be called, width and height would be assigned, and then this area can run. Similarly, I have created a class triangle inheriting the class shape in public mode. In public mode, I have one area function here also. So these three functions will get inherited in the public section of the triangle. Then this pure virtual function will see that I have the definition for myself in the public section. So I will run this. Overriding will take place. So let us see the main function now. Rectangle R, triangle T. Object of R is rectangle is created. Object of triangle is created. Then using the R, I am calling set width. Can I call set width using the object of rectangle? Yes, because set width is inherited here. So using the object of R, I am calling set width and I am passing 4 to W. That means width is equals to 4. Using the object of R, I am calling set height. As set height is inherited here, I can call it using the object of rectangle. So R is calling set height. So R dot set height 3. 3 will move to H and height is equals to 3. So width is 4 and height is 3. See out, area of rectangle is R dot area. Object of rectangle is accessing the area function. This is the area function. Return 4 into 3. That means return 12. 12 would be returned. And here the answer would be area of rectangle is 12. See, it is printed here. So how did we print this? We used the pure virtual function here. We did not define any body. Why? Because if we define the body of the pure virtual function here, it will restrict itself to that implementation only. But we have to define two implementations of this area in two different derived classes. That means we will use this area, this pure virtual function as interface. Once we will use it in some other way, and in the another derived class we will use it in some another way. That is called the interface. We are manipulating the body of a pure virtual function using our own different implementations. And as this pure virtual function is existing in this shape class is called the abstract class, and it is also called the interface. Why? Because we can define different implementations in different derived classes of this shape because of this pure virtual function. See now here, using the object of triangle t dot set width. Now 5 will go here, width is equals to 5. T dot set height, now height is equals to 4. So area of triangle is t dot area. Now as object is of triangle, so area of this triangle class would be executed. Return 5 into 4 by 2. That means 20 by 2, that is 10. Return 10. Area of triangle is 10 is printed onto the screen. So here we have defined one body for this pure virtual function. In another derived class, we are defining another body for this pure virtual function. So like this, we can make other derived classes also, and we can assign as many definitions for this pure virtual function. This is the beauty of this pure virtual function, that we can implement it in many ways using different implementations, using derived classes, as many derived classes, as many implementations. So that is why this class is being used as interface. We are using it as interface to find the area of rectangle one time. We are using it as interface for finding the area of triangle one time. Similarly, for other shapes also, we can find the area using this class only. This is the main class that is being used by inheriting it directly. That means all the functionality we have defined in a single class, now we can manipulate it depending on our shape. This is the beauty of interface, the beauty of pure virtual function. So I hope you have got the concept clear between virtual function and pure virtual function, and you know what is interface, what is an abstract class. Now let us come to the properties. Abstract class cannot be instantiated. That means we cannot create the object of the abstract class. See here, we can create the object of rectangle, we can create the object of triangle, but we cannot create the object of shape. We can only use it as interface. Okay. Abstract class cannot be instantiated, but pointers and references of abstract type can be generated. That means you can create the pointer objects like BPTR we created here. See, base class here, it is implementing pure virtual function. So it is an abstract class. As abstract class, we cannot create an object. So we created a pointer object here. We can create pointer objects and references, but normal object of base we cannot create. If you write base B, the compiler will give error. Okay, you can try that. Second point, abstract class can have normal functions and variables along with a pure virtual function. See, here there is normal function also along with the pure virtual function. So any number of normal function, normal data members can be there, but one pure virtual function is a must in abstract class. Classes inheriting an abstract class must implement all pure virtual functions or else they will become abstract too. I already told you, if this one is not implemented in the derived class also, then this pure virtual function which is inherited here will not be able to find its definition here. When it will not be able to find the definition here, this derived class will also become abstract logically. I hope you have got the concept clear for what is inheritance in public mode, overloading, overriding. Overloading is done when the class is only one and multiple functions of different forms are created in that class only. In overriding, classes are multiple, functions are also multiple, and same function is existing in the base class also and in derived class also. Then we saw the virtual functions using the virtual keyword. The virtual function will find the definition of its own in the derived class and we will implement it there. Pure virtual function will not have any definition in the base class, but we can assign as many definitions to the pure virtual function by building up different derived classes. In all the derived classes, we can give a different kind of implementation to the pure virtual function, and the class which will have at least one pure virtual function will be called abstract class. Abstract class cannot have any object, only pointer object can be there. And then we saw interfaces, that how abstract classes can be used as interface. We will save that class and we can build as many derived classes that will inherit that class and use the functionality. So this is all we have to discuss regarding virtual function, pure virtual function, abstract classes and interface. If you have any doubt, you can write it in the comment section. I will surely reply that.